Principles of flight. So basic principles of flight is a module which talks about the science of flying. Okay, how actually the aeroplane flies. This is one of the important topic from a perspective how drone flies or how aeroplane flies. Okay, the technology behind or the concept behind it, how actually we as a humans were able to take the flight and we are able to fly in the sky. Okay, so now let's see how and what is required and how this made possible. So first is fundamentals of flight, then aerodynamics, then what is takeoff, flight and landing, then maneuvers, turns and circuit patterns. Okay, so these are very important things when actually, so these topics are not only from a theory perspective but from a practical perspective also. We will be seeing them and will be when we are actually flying the drone, these will be applicable in our regular drone flying sessions. So for example, when I'm taking off, so how do I take off? So it is not only about doing the things, but before doing and while doing, we should be in clear, totally clear what action we are going to perform. Okay, like when I'm saying take off means take off. Okay, I'm going to land or touch down. Okay, or pitch forward, pitch back, roll right, roll left. You know, your right, your left. So this terminology we should know what is what, and accordingly we have to take the actions. Okay, so fundamentals of flight: aerofoil, chord line, relative wind, center of pressure, angle of attack, angle of incidence, center of lift, center of gravity, and Bernoulli principles. These are the important points what we need to understand when how the flight take place. Okay, so let's see by one what are these topics and what are these definitions of these points. Okay, so airfoil is a cross-sectional shape of a wing, blade, of a propeller rotor or a turbine. So what do you mean by cross-section? Any idea? Cross-section means what? Cross-section means a shape. We have cut it. Okay, laterally we have cut the shape of a wing and took the shape. So you can see this is a cross section of the wing. This is the cross section of the wing. So you see wing is something like this, a curved upper surface, whereas the below surface is a plane surface. Okay, so this is a airfoil section of a wing. Okay, cross sectional shape of a wing. Okay, this is called as airfoil. Now airfoil will have a leading edge. The larger curved surface is a leading edge, whereas where this upper surface and the below surface meet again back, that is called as a trailing edge. So there will be a leading edge and there will be a trailing edge. The upper will be curved surface, below will be the plane surface. Okay, this is called as airfoil section or airfoil. This is a cross sectional shape of a wing. Okay, now there would be, if we draw a line from a leading edge to the trailing edge. Okay, the chord line is a straight line intersecting the leading and the trailing edge of the airfoil. That is called as a chord line. So from, if you see from here, the leading edge till the trailing edge, we draw a straight line. Straight line is called as chord line. Okay, this is important when we see the angle of attack. So relative wind. What is relative wind? Relative wind with respect to the airfoil or with respect to the aeroplane. So now you see the flight is always in a forward direction. It will always move in a forward direction. The wind is moving in a opposite direction. So that is called as relative wind. Okay. So flight is moving in a flight path or forward direction. Your wind is flowing in a opposite direction. Okay. Or with respect to the airfoil. You can see here the airfoil shape of the wing, or even you see the tail part also, there is a airfoil section. Okay, so these are airfoil. So these are actually, you see the leading edge and the trailing edge. The sharper edge is always a trailing edge. The curved surface or the larger surface area is called as a leading edge. Now if you see with respect to the airfoil, the chord line is a straight line between the leading edge and the trailing edge. If you extend that chord line further up and you see the relative wind, there is an angle which is created. This angle alpha is nothing but it is called as angle of attack. Okay, the angle measured between the relative wind and the flight or the flight path and the chord line of the airfoil is known as angle of attack in aerodynamics. So this is angle of attack. Okay, now here you can see the wing is is curved as well as it is at angle. Okay, some angle. It cannot be parallel to the ground. It has always has to be little bit angle, upward angle. Then only there will be a lift. So if this angle is zero, there won't be any angle of attack. When you are not creating any angle of attack. Okay, if it is has to be some, you cannot have 90-degree also. I mean, you cannot have very big angle of attack also. What will happen? It will not lift. Okay, it will create drag. So you have to have a very precise angle of attack. This angle of attack is designed based on the design of the aeroplane. Okay, that based on the aerodynamics of that aeroplane. So angle of incidence is another angle between the chord of the aeroplane and the longitudinal axis of the aircraft. Now, how do you calculate the longitudinal axis? Longitudinal axis is from the tip of the aeroplane till the tail of the aeroplane. So that is a longitudinal axis. So there will be, you see, there is a aeroplane wing over here. That wing will always have some angle, which will based on the aerofoil, we'll see the chord line, and there is an angle formed between the longitudinal axis and the chord line. This is called angle of incidence. It can see, now your longitudinal axis is fixed, your chord line is also fixed, so it cannot be changed by pilot. So this is fixed. Angle of incidence is always fixed. Now this angle of incidence is important when you are designing the aeroplane. Okay, this will define when there is a relative wind flying in opposite direction, and your chord line will define your angle of attack. So as the aeroplane is running on the runway, throttle is given at certain point, the pressure difference will create the lift. We'll see that in future slides how this pressure difference will create the lift. Okay, so any questions so far on the airfoil, chord line, relative wind, angle of attack, and angle of incidence? Any issue in understanding, or you still need to understand something on that part? Let me know, or we can move forward. So these are very basic things which is required for understanding the flight. Okay. So now when aeroplane is in a flight, okay, there are four forces which are affecting on it. One is definitely the body, the weight of the body. Okay, that is what we call as gravity. So Earth will try to pull, because of the gravity, Earth will always try to pull the object to the center of the Earth. Okay, that is because of the gravity. Okay, the weight. Parallelly, because there is a body, there will be a friction in the air. Okay, the air molecules will try to oppose the motion of the aircraft. Okay, that is called as drag. Now, why that drag will, when the aeroplane is stationary on the ground, it will not have a drag. But as it starts moving in the air or on the ground also, when it is running on the runway, the thrust which is generated by the engines of the aeroplane, there will be a opposite direction, wind will be flowing. That wind will be basically try to push it. Okay, but aeroplanes are designed aerodynamically such a way that there is a minimal effect of the drag. We'll try to reduce as much as possible the drag, but we will never able to achieve drag as zero, because as far as the body is there, the surface is there, there will be always friction of or opposition of the air on the body. Okay, similarly, because of the thrust and angle of attack of the wing, there will be a lift. So lift is nothing but it's opposite of the weight. Okay, so lift will always act on the opposite direction of the weight, whereas thrust will always act in the opposite direction of the drag, or drag will act on opposite direction of the thrust, and vice versa. So clear on the four forces of the flight. When somebody asks you what are the four forces of the flight, you should able to tell the lift, which acts in upward direction, the weight, which acts in a downward direction, thrust will always act in a forward direction, whereas the drag will be act in a backward or opposite direction of the thrust. Okay, these are the four forces of the flight. Now let's see what is the principle of the flight. So in physics, a fluid is a substance that continually deforms or flows when external force is applied. Like this example we can explain, like if you see in your kitchen, okay, in wash basin, if you open the tap, the water will flow straight. If you hold a spoon and try to push the spoon in between the flow of the water will not stop over there. Water will try to curve around the spoon surface. This is called as Conda effect. So same thing, air is nothing but air is also considered as a fluid, okay, because it is made of gases only. Okay. Now this fluid includes liquid, gases, and plasma. When there is a external force is applied on the fluid, and the substance deforms or takes the shape of that particular surface, it is called as Conda effect. Okay, so the air that is following above the wings, it will have a Conda effect. Okay, now what happens because of this Conda effect? Okay, first let's explain the lift. Lift, again I said, perpendicular to the direction of the motion, difference in the pressure. Weight is downward because of the gravity. Drag is opposite to the direction of the motion. Friction and difference in the pressure. So drag is basically because of the friction and difference in the pressure. Weight is because of the gravity. Lift is because of difference in the pressure. So we'll see now how the Conda effect and these four forces come into the picture and make the flight possible. Okay, so to understand this concept of lift, we need to understand the Bernoulli principle. Now what Bernoulli principle says, the air is separated at the leading edge. So when air is attacked or air is pushed on the wings, it hits the leading edge and there it separates. Okay, so air is separated at the leading edge of the airfoil, rejoins at the trailing edge. So that means air will get separated and it will flow on the upper surface of the wing. It will flow below the surface of the wing, and again that air will join back at the trailing edge. So air has to move faster on the upper surface to cover the longer distance. Air flowing over the upper curvature wing will have more velocity. Since it is moving faster, it will have more velocity. The principle states, now let's see what Bernoulli principle states. This principle states that increase in the speed of the air occurs simultaneously with the decrease in pressure. तो जैसे ही आपका स्पीड बढ़ता है तो आपका प्रेशर डिक्रीज हो जाता है. Whereas decrease in the speed, okay, so velocity below the surface, there will be a decrease in the speed which will cause more pressure below the wing and produce the upward lift. Okay, you got it what I'm trying to say here? The air is separated at the leading edge and joins back at the trailing edge. So now there is the air is separated. So it starts from the leading edge, which air molecules will travel from the upper side. Some air molecules will be traveling from the below surface. Now when the air molecules are moving on the upper surface, it has to cover a larger distance. That means the amount time it has to take the same. So the upper air will fly more power, more velocity. So when more velocity, less pressure. Whereas below there is a low distance to cover. So the air will try to move slower. So since slower, decrease in speed will increase the pressure. So this pressure difference will cause the upward lift. Okay, so let's see now from pictorial perspective. You see here the air is coming from the front. Okay, there are difference. Okay, you are differentiated. The upper red is the upper surface, it is traveling. So this will have a high velocity of airflow, which will create a low pressure on the upper side. Whereas below side, low velocity of airflow, high pressure is created. Okay, so there is a pressure difference. Due to this pressure difference, lift is due to the pressure difference. There is a low pressure on the top and high pressure on the below. So automatically the wing will try to lift upward. Okay, so wing will lift upward, and that's how your aeroplane will take off. Okay, so as we are flying, I mean we are running on the runway. Okay, the aeroplane is creating a lift. At a right moment of time, the enough lift will be created where aeroplane will jump and glide in the air. You must have seen when we are taken the flight and when we are running on the runway, the aeroplane will be running at very high speed, and at particular point in time it will just take off and glide. So that's how the Bernoulli principle helps airplane to lift in the air. Okay, so any questions on the Bernoulli principle? So your fixed aeroplanes uses this technology or this concept. Okay, so that's why you need something to push it up in the air. Okay, mostly the runways are required for our aircraft to fly in the air, whereas your drone, the rotorcraft drone uses a different concept into it. Not only the Bernoulli, so propellers are designed for Bernoulli principles, but there is one more principle which is applied on the drone through which the drone flies. The drone doesn't only use Bernoulli principle; it needs another concept also. So before I move to the second concept, do you have any questions on the Bernoulli principle? Or you are clear, you understood how actually the aeroplane flies?
It's clear, sir.
Clear, right? Okay. So there are something called as Newton law of motion. I hope everybody has read or known in the school or colleges during our study. We would have read about Newton's law of motion. Now let's see how this Newton law are applicable to the drone. Okay, so what does first law states? That if body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at a constant speed unless it is acted upon by a force. Okay, for example, आपका ट्रेन जा रहा है, ट्रेन जगह पे खड़ा है तो ट्रेन will be stand still, right? The moment you start the engine, it is continuously moving the engine, the train will continuously move on the tracks, right? Until unless there is some दूसरा ट्रेन आके उसको ठोक नहीं देता है, तब तक वो अपने ट्रैक पे चलता रहेगा, right? It will keep on moving, until acted upon by a force. Until unless there is some external force is applied, it will keep on moving in that direction or that whatever the path it is traveling. Okay, it will keep on. तो अब ट्रेन आपका डिफरेंट डायरेक्शन में जा सकता है. अगर उसको कोई और ट्रेन आके ठोक दिया या सम व्हीकल आके ठोक दिया, बस आके ठोक दिया या समथिंग हैपन, देन ओनली इट विल गो हियर एंड देयर और समथिंग लाइक दैट. तो ऑब्जेक्ट एट रेस्ट विल रिमेन एट द रेस्ट until unless a net force is acted. मतलब ट्रेन अगर जगह पे खड़ा है, ट्रेन is standing still on the platform, it will be stand until unless you fire the engine or you power on the engine and you push, or else there is an engine which comes from behind and push that train body or train coaches. Still that time the coaches will be stationary. An object will be in motion and will remain in motion unless net force act on it. That means it will continue to move forward until unless there is any other force is applied on the body of the train or the coaches. Okay, so clear on the first law. Let's see the second law. Newton's second law is a quantitative description of a change that force can produce on a motion of a body. It states that time rate of the change of the moment of a body is equal to the both magnitude and direction of the force imposed on it. Means what? I give an example in the first law that train is moving. Okay, the body is moving. आपने suppose एक push दे दिया. The coaches are moving on a track. It will keep on moving until that force is working on it. Okay, if I increase the force of my engine, what will happen? My coaches will start moving more faster. Acceleration will be created. The more force, the more acceleration. So as I give the more power to my engine, the engine will force the coaches to move more powerful. Okay, so that force is nothing but mass into acceleration. मेरा इंजन कितना फास्ट जा रहा है और कितना पावर दे रहा है, that will create the force on the body, and that's how my engine will move, or sorry, my coaches will move faster. Okay, that's it about the second law. So the force is equally mass into acceleration. Okay, अगर opposite सामने से अगर मेरा कोचेस आ रहा है और opposite direction मैंने उस पे force apply किया, तो क्या होगा? The coaches will decelerate or will stop, or there will be a collision, right? So collision is also some kind of a force applied on the body, but it is in a opposite direction. If I am applying the pressure or the force in the same direction, it will accelerate. If I apply force in opposite direction, it will decelerate or collision will happen. Okay, that's the Newton's second law. Now the important is the Newton's third law. This is which is applicable to your drone. Okay, your drone actually flies because of the Newton's third law. Now what does Newton's third law says? Newton's third law states that when two bodies interact, they apply forces to one another, then that are equal in magnitude and opposite in direction. So Newton's third law is also known as law of action and reaction. So example like your rocket. Okay, rocket is stand still on the launch pad. What will happen? It will be stand still because of the Newton's first law of motion. Okay, उसको अगर acceleration नहीं दोगे तब तक वो जगह से हिलेगा नहीं. So what we'll do is we'll fire the rocket. Now what is rocket trying to do? It will try to push the gas, okay, that explosion जो होता है, chemical reaction जो होता है, उसके वजह से जो high pressure gas है वो nozzle से बाहर आता है. Now what is that gas trying to do? When the gas is escaping from the nozzle, it is trying to push the ground. But can rocket push the ground? Is it possible for a rocket to push the ground? No, the rocket cannot push such a big earth. Okay, it is a very small, tiny object. So क्या होगा? Opposite action होगा. So rocket will start rising. Okay, so it will start rising from the launch pad and it will go up. Okay, so it will continue to go up till the, suppose in between हमने कुछ हो गया, हमारा फ्यूल खत्म हो गया या बर्न हो गया या ब्लास्ट हो गया कुछ हो, तो क्या होगा? Rocket will travel certain distance and it will fall back. But in case our rocket is good, flying at very high speed, आपने देखा रहेगा इसरो जब रॉकेट लॉन्च करता है या नासा रॉकेट लॉन्च करता है, they have a big booster rockets on the side. They are solid powered rockets. Okay, so they will generate a huge pressure hot gas which comes out, push the rocket at very high speed and travels at a very enormous speed into the space, so that it is out of the earth's gravity. So earth gravity cannot pull it back. वो अर्थ ग्रेविटी से एस्केप कर लेता है, जैसे ही वो अर्थ ग्रेविटी से एस्केप करता है वो फ्री हो जाता है, बट स्टिल द रॉकेट इज फायरिंग. फर्स्ट स्टेज हो जाएगा, सेकंड स्टेज होगा, थर्ड स्टेज होगा. सो लाइक दैट इट विल गो एंड देन इट विल गो इनटू द ऑर्बिट अराउंड द अर्थ, राइट. तब तक थर्ड स्टेज तक आ जाएगा, तो उसके अंदर का वो स्पेसक्राफ्ट बाहर आ जाएगा, एंड देन दैट स्पेसक्राफ्ट विल आल्सो हैव सम रॉकेट इंजिन्स अटैच्ड टू इट, और स्मॉलर cryogenic engines would be there which will be firing the rockets and controlling its motions and movements and all that thing. So that way your spacecraft is in space. Okay, same way the drone is there. So drone क्या होता है? 4 copter है, 4 rotors है, तो क्या करते हैं? घूमते हैं. So as they are rotating, okay, it is creating a pressure. Okay, so it is pushing the air below. So what is all the 4 propellers are trying to push the air below? It is trying to push the earth. बट अर्थ को तो पुश नहीं कर पाएगा ना, इट विल नॉट एबल टू पुश द अर्थ बिकॉज इट डजंट हैव दैट मच फोर्स. देन व्हाट विल हैपन? द ड्रोन विल स्टार्ट राइजिंग. सो एज यू गिव थ्रॉटल, मोर एंड मोर थ्रॉटल, ड्रोन विल try to rise. It will rise in the space or in the sky and it will go up in the flight. So it will go up. The beauty of the drone or the rotorcraft is that it is able to hover. Whereas हमारा क्या होता है? हम एंगल देते हैं एरोप्लेन पे, क्या देते हैं हम लोग? विंग्स को एंगल देते हैं, एंगल ऑफ अटैक चेंज करते हैं. उससे क्या होता है? हमारा एरोप्लेन हवा में जंप करता है, ये लिफ्ट हो जाता है. सो एज इट लिफ्ट वी कंटिन्यूअसली गिव द थ्रॉटल टू इट. ओके, इंजन हमारे कंटिन्यूअसली चालू. अगर इंजन बंद करेंगे तो क्या हो जाएगा? व्हाट विल हैपन इफ आई क्लोज डाउन द इंजन और शट डाउन माय इंजन व्हेन एरोप्लेन इज फ्लाइंग? Since aeroplane is designed aerodynamically, it will still glide. It will not automatically fall down there itself. It will, since aerodynamically designed, wings are designed in a such a way, it will glide. Okay, the pilot can make aeroplane glide to certain extent, kilometers. मतलब it can fly up to 10-20 kilometers. वो glide होगा, but because of the weight and since there is no thrust, that means no power, there is no engine working on it, तो क्या होगा? ड्रैग विल स्टार्ट एक्टिंग ऑन इट. सो ड्रैग विल कॉज व्हाट? उसको स्लो डाउन करने की कोशिश करेगा. स्लो डाउन करेगा तो क्या आएगा? वेट इंक्रीज होगा. वेट इंक्रीज होगा तो क्या होगा? इट विल स्टार्ट डिसेंट. सो योर एरोप्लेन विल स्टार्ट डिसेंट. सो ग्लाइड होता रहेगा, सर्टन एंगल एडजस्ट करके पायलट विल ट्राई टू मेक इट लिफ्ट, थोड़ा ऊपर नीचे कर पाएगा, बट नॉट एफिशिएंटली व्हाट इट वाज एबल टू डू बाय द इंजिन्स. तो अगर उसको वापस प्रॉपर फ्लाई करना है तो उसको वापस इंजन स्टार्ट करना पड़ेगा. कभी कभी होता है ना, इंजन में आग लग जाता है तो पायलट विल पुट ऑफ द इंजन, वो आग बुझ जाएगा, आई मीन इट विल एक्सटिंग्विश एंड देन ही विल रीस्टार्ट द इंजन टू सी वेदर ही कैन स्टार्ट द इंजन प्रॉपर्ली और नॉट. अगर प्रॉपर्ली हो गया तो नहीं, तो फिर उसको इमरजेंसी लैंडिंग करना पड़ेगा एंड ऑल दैट थिंग्स विल हैपन. So that is what is there in the aeroplane. Whereas in the drones, normal drones, अगर suppose आपका एक मोटर फेल हो गया, तो what will happen? It will become imbalance. It will become imbalance. It will try to fly on the 3 motors, but it will not be stable. At one given point in time, it will crash. Okay, so that is the drawback of a drone. So if you are having a quadcopter or hexacopter, you have to have all the motors running at the speeds, same speed. There is a imbalance would happen if your motors are running at a different speed, or all of a sudden one or two motors fails, your drone will crash. So clear how normal aeroplane flies and how the drone flies. Any questions so far on this? Parag, Aniruddha, Jayshil, Jagjit.
No, sir.
No, sir.
No, sir.
Clear.
So no questions on this, sir, but there will be an influence of wind and direction also, right, in this?
That will come in external force. We'll see. Okay,
Okay.
there definitely on the aeroplane wind as well as on drone. Whereas impact of the wind is not much on the aeroplane because they are aerodynamically designed. Whereas your drone is not aerodynamically designed. Okay, so there will be definitely effect of wind on the drones or the rotorcraft. But rotorcrafts are moving at very high speed. They are able to counteract the wind speeds. But
Okay.
certain wind speed, it is not advisable to fly the drones.
Okay. So is there a way in which it will be, one person can decide, I'm sure there would be a way in which you can monitor how the wind is, whether the condition
That is
is
yes, yes,
conducive to fly or not to fly.
yes, yes. We have a topic called weather and meteorology.
Okay.
Okay, so in that we'll see what knots, what flying, what wind direction, how it is
Okay.
going to impact, what's wind speed we are not supposed to fly, and all that things, and how to
Okay.
find when we are actually supposed to do the operations.
Okay.
Okay,
So
then
the application that supports the drone will have these parameters covered in that, right?
yes, yes. Even when you are flying, your RC will know at what speed it is. Flying. The drone is flying,
Okay.
and all that parameters will be there.
Okay. Okay.
Okay, so that's about the Bernoulli principles and Newton's third law. Okay, there is something called as center of lift. So center of lift is nothing but the average of the lift force through which all lift is considered to act. It's the same as center of pressure. Okay, whereas center of gravity is the balance of the aeroplane or balance of the device. Okay, if you see the aeroplane, the center of gravity is always little bit away or in front, considering the center of lift or center of pressure. Okay, so this is basically at the center of the all the three axes. Okay, so normally even your center of gravity would be somewhere here, but to fly or bring the efficiency in the flying, you always make the center of gravity little bit further from the center of lift or center of pressure. That is what we called as nose heavy. So you will always see that aeroplane is always heavier in the front compared to below. हम लोग जब घर में when we were young, we used to make a paper aeroplane. So we normally used to make the paper aeroplane. तो हम लोग normal nose थोड़ा सा thick बनाते थे या heavy बनाते थे, right? Then only aeroplane flies properly. अगर उसको लाइटर करके देखो तो क्या होता है, वो फ्लाइट ही नहीं होता है आपका. Okay, so your front part of the aeroplane or the aircraft has to be always heavy. Okay, so you see always the design of the aeroplane backside थोड़ा taper रहेगा, छोटा रहेगा, not much. So your wings will be centered. Most of your luggage and all that things will be in the belly of the aeroplane. Even if you see the rocket, okay, even if you see the rocket, multi-stage rocket, as you are when your rocket is there, 4 stages, still you will have the front part heavier. Okay, as it goes up in the air, the first stage will go, it will reduce its weight, but still the weight is in top because the final spacecraft is it in the top portion. Okay, they always packed it in the top portion. फिर second stage निकल जाएगा, third stage निकल जाएगा. By the time it reaches the space, it is in a fourth stage. Okay, still the weight of that motion or the rocket is still in the top part. So heavier part is always on the top. ओके, सो आपका हैवी रहेगा, लास्ट में आपका फेरर ओपन हो जाता है और आपका छोटा सा स्पेसक्राफ्ट विल कम आउट फ्रॉम द रॉकेट एंड देन इट विल फायर इट्स ओन इंजिन्स. ओके, but by that time that motion or that what we say that acceleration will be there, like as the aircraft is ejected from the main rocket body also, so that same pressure will be transferred to the aircraft also. Okay, so center of gravity, point at which the aircraft would balance where it is possible to suspend at its point. I can bring the center of gravity exactly at this point also by adjusting the weight, but I will always make sure that when center of gravity is always little bit ahead of center of lift or center of pressure. Okay, and then you have horizontal and vertical stabilizers for balancing the aeroplane. Okay, so balancing the tail load, so that is done by the horizontal structures. Okay, the horizontal wings on the back side of the tail. Okay, so what is aerodynamics? Aerodynamics is the study of how gases interact with the moving bodies. So nothing, gases means air. Okay, you should think about air, because air is also made of gases. Engineers apply the principle of aerodynamics to design of many different things, including buildings and bridges. Like we design aeroplane using aerodynamics. Even the cars are been designed by using aerodynamic principles. Buildings, the huge buildings like Burj Khalifa, or big towers, especially you are seeing towers which have been made in South Bombay and all the things. You will see their surfaces are more or like curved surfaces. Okay, even the bridges are been designed in a such a way that they are supporting the aerodynamic. The airflow should become very smooth. They should not create any hindrance or hindrance for airflow. So that's way how the bridges are also designed. Even if you see the Vande Bharat which has been designed, see the front part of the train. It is curved surface. Aerodynamic. Or bullet train in Japan. We'll be having a bullet train also running in between Mumbai to Ahmedabad also in some time now. So you'll see there already Japan has given us two types of bullet trains. They are like a shape like like a kingfisher, or maybe like a whale. Pointed nose cones are there. So they are all aerodynamically designed. The primary concern of aerodynamics are aircraft and automobiles. As I said, aerodynamics comes into the play in the study of flight and the science of building and operating an aircraft, which is called as aeronautics. Okay, so aeronautics is study of science for building and operating an aircraft. Okay, so now as we are talking about aeroplane, let's see what are the control surfaces are there on the aeroplane. Now these are very important with respect to when we are flying the drones. Okay, especially the aeroplane type of drone, or maybe even in the drones also. Okay, let's see how these are applicable. So if you see the aeroplane, there is a round structure which we call it as a fuselage, and you will have two wings on either side. Okay, these wings will have a control surfaces which are called ailerons. Okay, so these ailerons which cover creates the shape of the wing for flying purposes. Okay, or the lift purposes. The ailerons are on the wings. Okay, so there will be a question. Wings, where are the ailerons? Okay, where are the ailerons? So ailerons are on wings. Whereas on the tail section, you have two things. One is horizontal stabilizer, and there is a vertical stabilizer. The horizontal stabilizer, you will have elevators. So elevator will control your pitch. Elevator will control the pitch. Matlab aeroplane either it will move up or either it will move down. Whereas rudder will control the direction of the aeroplane. So rudder is nothing but a vertical stabilizer on which there is a rudder section backside. Okay, so rudder आपका left right move होता है, whereas elevator up and down move करता है. So your aeroplane can pitch up or pitch down. Whereas on the wings you have ailerons. Okay, ailerons are required to bank the aeroplane or to create a roll. Okay, so when you impact the ailerons up and down, so left side का ऊपर जाएगा, right side का नीचे चला जाएगा. So when that is happen, that is called as the roll motion of the aeroplane. So I will just put on my camera. Okay, and I will show you how. For example, this is my mobile. Okay, so what is, see, this is mobile, this is front, I mean assume this is aeroplane. So I'm moving forward. This motion, okay, this motion is called as roll motion. Okay, or by hand you can show you, this motion is called as a roll motion. Okay, so this is roll right. Okay, whereas this is roll left. Okay, roll right, roll left. When I am elevators are acting. Okay, so what I am doing, I am raising the nose. So this is called pitch up. When I am elevator down, so I am saying pitch down. So I am going down. So pitch up, pitch down. Okay, roll right, roll left. And then because of the rudder, what I'm trying to do is I'm trying to change the heading or direction. So this is called as yaw. Okay, this is called as yaw. So yaw right, yaw left. Okay, so these are the three motions which we do into the aircraft. Whereas in drone, there are four motions. Okay, so there are four motions. Same like your aeroplane, your drone. If you have a drone like this, okay, your drone is on the ground. You will power it up. You will go it up in the sky. This is called as throttle. Throttle means upward direction. Throttle up, throttle down. Okay. Now, like how you have aeroplane forward motion, in drone forward motion is called pitch forward. Pitch forward. Okay. When it's coming back, it is called as pitch back. Pitch back. It is moving away. Okay, from the position. Forward जा रहा है आपसे forward. You are a pilot in command. You are outside. So when you are flying, so with respect to you, when drone is moving away from you, it is called pitch forward. When it is coming towards you, it is pitch back. When you are moving backward direction. Okay. Whereas this is roll. Okay, roll. This is roll right. This is roll left. Roll right, roll left. This, if you are moving the drone in this direction, you are changing the heading. It is called as yaw right. When it is moving on the right left side, it is called as yaw left. Understood how the four motions are there? When we are flying the drone, we will be doing these exercise every time we are flying the drone. These are called as pre-flight checks. Sorry, flight checks. These are called flight checks. Okay. Once your drone is in air, first thing you have to do is you have to do a flight checks. So you have to push the drone, pitch forward, pitch back, roll right, roll left, yaw right, yaw left. So all these exercise you have to do, and then you have to proceed with your procedure. Either you have to be creating a square, you have to create a triangle, or you can create a rectangle, or you might be creating a circle, whatever is been instructed to you. And then again with different control surfaces. Like I would tell, okay, only use pitch and yaw, only use roll and yaw. That way I will tell you to do it. So you have to apply controls accordingly on the drones. That is how you will learn how to fly your drone. Clear? Any questions on here? So when you are flying the drone, these are the important concepts you need to know. You need to follow the concept. When you are using the joysticks, you should know which joystick controls what. So joysticks, you have two joysticks in your hand. You will be controlling two channels with each joystick. One joystick will controlling two channels. Well, one joystick will responsible for pitch and yaw. One joystick will be responsible for throttle and roll motions. Like that. So they will be something like that. We'll see which joystick controls what. Okay, in the subsequent slides. So for any questions on the, so there are some additional control surfaces also there, like spoilers or flaps or slats are there. These are called as secondary flight controllers. So primary flight controllers will be always there on all the aeroplanes. What I'm saying, all the aeroplanes. Like for example, you are flying a small aeroplane, Cessna, or World War II ka fighter plane, any fighter plane. You will always see these three primary flight controls on all the aeroplanes. That is ailerons, elevators, and radars. Okay, so these will be always there on, irrespective of whatever the size of the aeroplane. Whereas additional controls, there are secondary control surfaces like spoilers, flaps, or slats. This will be only there on a bigger aeroplanes. Okay, like Boeing aeroplanes, Airbus, big size aeroplanes, it will be there. These are nothing but these are additional controls, okay, or additional fine tuning controls. Like here you see this is a big aeroplane. So you can see here the rudder is divided into two sections. Okay, sometimes rudder will also have a small section So it is just to fine tune more effectively. The flying becomes more smoother and flying. Okay, so you will see there are ailerons. Okay, there are spoilers and flaps. Like these flaps and spoilers are useful when you are landing. Okay, slats are useful when you are actually want to increase the bigger lift or a higher lift or a shorter lift की जगह पे छोटे एरिया में या छोटा रनवे पे आपको जल्दी टेक ऑफ करना है, तब आप slats use करते हो. Okay, so depending upon conditions, you will use the control surfaces. Whereas primary control surface will be always there on the wings or on the horizontal or vertical stabilizers. So any questions on the control surface? I hope you have understood the concepts, how the aeroplane flies now with help of the principles, that is your Bernoulli principles and Newton's third law of motion, and then how control surfaces affect your flying or how it is controlled. How the aeroplane turns in the air, how aeroplane rises or changes its altitude up and down, or how aeroplane banks on left and right side. So normally banking is not used in commercial airplanes. This banking you will see in jet airplanes, especially the fighter airplanes. There where the maneuvers are required, you need to aeroplane, the commercial aeroplane or civil aeroplane, you can't fly like that. You have to be always have a steady flight because there are hundreds of passengers are there into that aeroplane. So you can't have a turbulent kind of flying. Whereas jet aeroplanes or engines, the aeroplanes which are used for fighting, okay, or warfare, those are being used by only one or two people are there. So they are being trained for that kind of maneuvers and those kind of operations. So all of a sudden they will rise, they will vertically go up. All this is possible because that aeroplane is very small and it has very high power, enormous power is there. So it is able to overcome. अगर वही चीज अगर हम लोग ये एरोप्लेन के साथ करने की कोशिश करेंगे, हमारा एरोप्लेन 2 मिनट में क्रैश हो जाएगा. We cannot perform those maneuvers with the normal civil or commercial airlines, okay, or aeroplanes. Clear? Any questions so far?
No.
So again, axis of flight, as I talked about, if you see longitudinal axis is nothing but from the tip of the aeroplane till the tail of the wing. This is basically aileron. Okay, so here your drone will try to roll. Okay, so ailerons आप move करते हो, ailerons are on the wings. Okay, so you will try to bank or roll. This is called as a roll motion. Whereas if you see lateral axis, which is parallel to your wings, okay, तो इसमें क्या होता है आपका pitch. So it is controlled by the horizontal stabilizer on the tail. Okay, so as you move your elevators, the pitch will affect. Okay, so pitch will come into the picture. Either it will pitch up or pitch down. Whereas at the center you will have a vertical axis. Okay, so this is here your vertical stabilizer. Okay, the radar will actually change the direction. So you see this green line. Okay, so it will change either left side or on the right side. Okay, so aileron, which is results into the rolling motion of the net, its effects on the longitudinal axis. Okay, whereas elevators or stabilizers, which are help for the pitch moments, which will be a lateral motions. Whereas radar will be called as yaw. Okay, in aviation terminology, radar or the direct change of the direction is called yaw motion. Okay, so it is yaw motion which is with help of the vertical axis. Okay, so any questions on axis of flight? You need to visualize this. Okay, when you have visualized this, when the aeroplane is flying, simultaneously when you are flying the drone, also you have to visualize. Okay, when you are saying roll right, मतलब क्या हो रहा है? Roll right, roll left. Okay, pitch forward, pitch back, throttle up, throttle down. Okay, and then last is yaw right and yaw left. Okay, so these are the motions what we normally follow into the drone operations. Okay, now takeoff, flight and landing. Takeoff, it is a phase of a flight in which an aircraft goes through a transition from moving along the ground to flying in the air, usually starting on a runway. So takeoff, हम बोलते हैं ना, the aeroplane after the taxiway, it will come to the end of the runway, and from there it will start. Okay, so it will start running on the runway, and at particular angle, when the angle is created and enough thrust is being generated, your airplane will take off. Okay, so normally if you are sitting, since you are sitting in a cabin, you will not know what is the pilot is talking. Okay, so there is a point on the runway which is called as V1. Okay, so V1 is a point. As it crosses the V1 point on the runway, the aeroplane has to take off. It cannot stop, so it has to take off and go into the air. Okay, so V1 position जैसे ही क्रॉस करता है, the co-pilot will say V1. Okay, that means now the pilot knows that we have crossed, we have to give more throttle, we have to give the angle of attack so that airplane takes off. Okay, so that is the position when you will take off your aeroplane. Now flight is nothing but it's a steady flight when it is moving in the space, okay, or in the sky. It is the forces by which an object moves through an atmosphere, okay, without contact to the ground with the surface. This can be achieved by generating aerodynamics lift associated with the propulsive thrust. That means your engines needs to be continuously moving, continuously rotating. Okay, so that is the propulsive thrust what I am giving to the aeroplane. So that's why my aeroplane is always moving in a forward direction, and I am maintaining my angle of attack. So that is how I am managing my flight at a steady flight. So that is what I am trying to do as a pilot when I am flying the. अगर मैंने angle of attack नहीं manage किया तो क्या होगा? My aeroplane will start going down. Okay, so I have to manage that. So in a commercial flight, this is been managed by either by the pilot when you are flying a small aeroplanes. But when you are flying a commercial aeroplanes like especially Boeing's or Airbus, this is been done by the. Can you think who does this? Any idea?
Co-pilot.
Co-pilot nahi. Co-pilot, pilot are both same.
So then it is by the computer itself.
Yes, that is called as autopilot. Okay, so autopilot does it. Normally manual mode में आपको pilot को करना पड़ता है, वो manage करना पड़ता है. He feels like when you are flying the aeroplane, you are inside the aeroplane, you know how the aeroplane is moving. जैसे कार चलाते हैं तो हमको पता है ना, we become a part of the car and that's how we know how to drive the car. Similarly, जब आप aeroplane fly करते हो तो pilot को पता रहता है aeroplane fly कैसे हो रहा है, तो he know what to manage. जैसे हम लोग kite उड़ाते हैं, when we are flying a kite, we are holding the string, we become the part of the flight of the kite itself, and we know now what is to be done, whether we have to give a push or whether we have to give a release of the string that will make the kite fly up and down. Okay, so similarly when I am flying the aeroplane in a manual mode, I know how to balance my flight. अगर मैं सो गया तो क्या हो जाएगा? मेरा एरोप्लेन नीचे चला जाएगा, right? It will crash. So in a commercial airplane, normally these activities are taken care by the autopilot. In fact, in commercial aeroplane, pilot doesn't flies the aeroplane. Pilot is only sitting in the cabin, monitoring, following the checklist. When it goes on the taxi हो रहा है, okay, taxi कर रहा है. When it is on, once it is on the track or it's on the runway, he gives the throttle. It is taken over by the autopilot. Autopilot will do the takeoff. It will, you only feed the inputs. Like ATC tell you that take your aeroplane to 10,000 feet. You will feed that input. Autopilot will take your aeroplane to 10,000 feet. ATC tells you to take your flight to 15,000 feet. If you will feed that settings, the autopilot will take the flight up. ATC tells you to descend 5,000 feet. You will set that setting. Autopilot will take your aeroplane to that setting. Landing will also come as per your flight plan. Everything will be aligned and autopilot will land your aeroplane. It is not the pilot who is actually landing the aeroplane. It is autopilot who is actually landing the aeroplane. तो आप जितना भी आपने फ्लाइट्स लिया होगा या ले रहे होगे, everything is taken care by the autopilot. Pilot normally doesn't flies the commercial airplanes. They are not supposed to touch any controls until unless they have approval or they are authorized to do. Everything has to be done by the autopilot only. Clear? Now as we move, so your flight is happening, okay, someplace it will come to its destination, and it is the last part of the flight where the airborne aircraft returns to ground. When flying object returns to the ground, the process may also be called as touchdown. Okay, so normally when we land the drone or when we land the aeroplane, we see normally say touchdown successfully, or when we are going into the landing position, we say that proceeding for landing. Okay, so these are the terminology. These are the terminologies what we will be using when we are actually doing our practicals. Okay, so you will normally see, okay, taking off the drone, throttle up, okay, pitch forward. When you're getting your drone down to land, so you are saying initiating landing, touchdown. Once it has been done, once it lands on the ground, you say touchdown successfully. So these are the words used to say like touchdown successfully, battery 30%, battery 50%, battery 40%, whatever it is, you need to say these things. Simultaneously, when you are taking off, before that, there are certain parameters which you need to verify. Like, for example, you want to verify whether there are any notifications on the control or not. So you will see those. Okay, so once you are clear, there are no errors and anything, you will tell your co-pilot to put off the
Sir,
safety
sir, can
switch.
you, sorry to interrupt, can you repeat this sentence again because I lost your voice there.
Okay, okay. So where did till what you heard?
No, this sentence, the start of it,
Okay, so I am saying when you are actually trying to take off. Okay, for example, when you are trying to take off, you need to
pre-takeoff checklist is what you said, and
takeoff checklist. You need to see certain parameters. Like first, you have to see any warning or any notification is there. Okay, sometimes GPS malfunction, yeah, फिर compass calibration not proper, or some kind of errors would be there. So you need to see that there is no errors. Your takeoff is error free. Okay, there are certain safety patterns are there. So drone example, I'm talking about drone or even aeroplane. So it will always try, the computer or the flight controller will try to check everything. जैसे हमारा पीसी में या लैपटॉप जब चालू करते हैं तो क्या होता है, इनिशियली बायस चेक होता है. तो बायस चेक क्या करता है, वो सारे पैरामीटर्स चेक करता है कि सब कुछ बराबर है, then only OS will boot up, right? And then your laptop or desktop will start. Similarly, aeroplane या drone भी start करने से पहले there will be checks happening. So that will be check happening, and it will give you, if there are errors or something is not proper or normal, it will give you the indications. If those indications are there, you need to rectify them. You cannot ignore them and start or fly the drone or aeroplane. Okay, so you need to rectify them. Everything needs to be clear and normal, then only you should take the flight. So once you are clear on your indications, probably you might see what is the battery percentage, probably you might see what is the GPS count. Okay, you might see what is the mode of your flight. Okay, there could be a wind speed also is required, so that also you could see it. All these parameters you will see, and then you will take a decision to fly the aeroplane or fly the drone. Once you are in the air, your drone needs to be at a level flight. Okay, you need to fly the drone at a level flight. So you will maneuver as per your requirements, and you will fly the drone accordingly. Once you are completed with your task, you will be going for landing. So you will initiate the landing procedures, you will land the drone, and then you will see final, like before handing over or before shutting down the drone, you will say that what was the landing and status of your battery and other parameters. Okay, so that is called as post check. Okay, even you shut down, I mean you put off your drone is been powered down, you need to check whether there are any damages, whether there are any stress, cracks, or any issues physically also on the drone. That is how you close your activity of your drone flying or aeroplane flying also. Even when commercial aeroplane flies, before the flight, the pilot actually takes around a visit around the plane. He will himself will also inspect. He, as a pilot, his job is to fly the aeroplane, but from his perspective, he will verify certain parameters on the aircraft. But there is an engineer, okay, there is a dedicated engineer whose job is to run hundreds of checks or hundreds of parameters to verify, and he will be having a checklist which he will be tick. He'll be tick everything, parameters, whatever is, whatever the options they need to check, he will tick, and then he will hand over that checklist to the pilot to just to see that there are no errors. So pilot will verify that checklist and whether see there is any error pointed out by the engineer or any issue pointed out by the engineer. If there are any issues, there is going to be rectified, or pilot will not take the aeroplane in his control, or he will not be ready to fly that aeroplane. If everything is normal and everything is okay, then he can proceed for cockpit. So he will go into the cockpit, and again in the cockpit also they have a different checklist to follow, because there are a lot of buttons, lot of things needs to be start, check, and all that things. And once they have done through their checklist, they will go on a taxi mode. After the taxi mode, they will go to runway, and then they will. So every point in time, there are checks which are to be done. Okay, so like when you are on a taxiway, whether you are on a right taxiway or not, whether you are on the runway, whether you are on the right runway or not. Like Mumbai airport has two runways. Sometimes you can go on the wrong runway also, or a wrong path of the runway also, wrong part of the runway also. Like bigger airports, like Heathrow Airport in London, which has multiple runways. Okay, so then sometimes people go on a wrong runways also, lot of times. So these are needs to be corrected, verified with help of ATC or the co-pilot also. Okay, so that's why it is, so that's very critical, very stressful job is there, though it looks very simple and good and prestigious kind of thing, but then in itself it has its own drawbacks also, or there is a stress and pressure also, because it's not only about the aircraft, but there are hundreds of lives is in your hand. Okay, when you are flying the drone, flying the aeroplane. Similarly, when drones will be flying, you will be doing for some activity, some project, or maybe you will be flying a drone taxi or something like that. So that time it will be more crucial for a pilot to be sensible and responsible when he is doing his activities. Okay, so that's about the takeoff, flight, and landing. So in the landing is very crucial. Your landing has to be very smooth. You have to do the landing proper, because takeoff is nothing, takeoff is simple. You are see your aeroplane is more safer when it is on the ground and when it is in air. When it is taking off or when it is landing, that time it is very vulnerable. Okay, so you have to be careful. So when you are taking off, it is very simple, because you just have to push the throttle. Your aeroplane will be in the air. It will, as far as it is in the air, it is safe. As it lands safely, it is safe. But the middle portion during the takeoff, when it is closer to the ground, or when during the landing when it is closer to the ground, that time, that what we call that, the challenge of push tug war is happening between the drone or the aeroplane with the earth's gravity. So we have to balance that thing. Sometimes, if the gravity pushes more, your drone will crash or your aeroplane will crash. Simultaneously, when you are landing, you have to make sure that you are smooth landing the drone or aeroplane. So you have to balance that pressure which is pulling it down and the upward motion. आप ज़्यादा upward motion दोगे तो क्या होगा, आपका landing होगा ही नहीं. You will go up in the sky. Okay, so you have to balance that. Okay, you have to manage or balance the downward push and the upward push, so that you are slowly stable way you are landing your drone. Okay, so normally in our flying, will always follow a emergency procedures. Okay, which is a smooth landing. Okay, so we'll also have to know how to do a emergency procedure. So we'll be regularly flying our drone manually, but when we are landing, we'll always do it in a emergency procedures. So every time we'll fly the drone, we'll land the drone using RTL. Okay, so we have to make sure, because RTL, we need to know how to put the drone into the RTL mode, and then it has to go into RTL mode and it has to land. So even in that, even though it is automatically landing the drone, that is very crucial, because even during automatic landing, the mishaps can happen. So you need to observe continuously, monitor. In case the RTL is not happening properly or issue, you should able to break that sequence. Okay, and you are able to take the drone little bit higher up in a safer place, and then again initiate the landing. Okay, so you should able to do that. So that is called as emergency procedure during the flight. Okay, so that's about the takeoff, flight, and landing. So when our flight is in a stable flight, will normally perform the maneuvers or turns or circuit patterns. Like when you fly the drone, after your pre-checks are done, I will ask you to create or fly the drone in square format. Okay, so I will try to tell you, okay, do a right square or do a left square or do a left reverse square or do a reverse right square. Okay, accordingly I will tell you the pattern, so you have to follow or do that pattern. Then I will tell, okay, do the right square using only pitch and yaw, or only using the pitch and the roll, kind of thing. So I will tell you what is to be done, how it is to be done. Accordingly you have to fly the drone. So these are nothing but these are called maneuvers, turns and circuit patterns. So one is the straight and the level flight, where we are just moving in a forward direction. Then we'll be doing something called as a turns, left and right turns. And then probably we'll have two options. One is climb. That means we'll climb higher up in the air, or we'll have a descent. So you will always have a straight and a level flight using the drone, using pitch forward, pitch back. Turns can be done using your yaw motions. Okay, so yaw motion, yaw right or yaw left. Climb and descent will always happen using throttle. Okay, so these are the controls what you will be flying. So normally this type of a flight, when you have taken off and then you're flying in a square or a circle and then again back landing, normally this happens in a test flight or during your training sessions only. In a normal commercial flight, आप बॉम्बे से टेक ऑफ करके बॉम्बे पे लैंड करोगे कभी? No, right? You will never do it. It will be only done in case of kind of emergency. Okay, but most of the time your flight will take off from Bombay and it will go to its destination. Destination could be Delhi, destination can be Calcutta, destination can be Chennai, destination can be Bangalore also. Whatever your destination is there, based on that destination, it will fly from Bombay and it will descend and land at that particular destination or location. Okay, so you will start with descent and then you will land your aeroplane with the respective location. Okay, so this is how normally the circuit pattern is used by the students when they are learning the pilot flying. Okay, the aeroplane flying. Okay, so they will be taking off from the same runway. They will change their orientation of the aeroplane. They will go crosswind, then they will go downwind, then they will go for a base leg, and then they will land at the same landing strip as called as flying leg. Now, if you see from a commercial part, this blue and this part, okay, half of this part would be at from the same airport, whereas this half of the purple base leg and the final leg could happen on a different airport. Okay, in a commercial airlines. Clear? Any questions so far? If no, we'll move forward. Okay, so with that, we complete our basic principles of flight. So when we talk about the basic principles of flight, let's summarize only two things. One is the airfoil, what you need to understand, the leading edge and the trailing edge and the cross-sectional shape of the wing. The chord line is nothing but the straight line joining the leading edge and the trailing edge. Okay, that is the chord line. The relative wind is the direction of the airflow with respect to the airfoil. Angle of attack is nothing but with respect to the chord line and the relative wind. Whatever the angle is created, that is called as angle of attack. Angle of incidence is again with the angle with respect to the chord line and the longitudinal axis. The longitudinal axis is nothing but axis from the tip of the aeroplane till the tail of the aeroplane. Okay, the angle what it creates with help of longitudinal axis and the chord line is called angle of incidence. It cannot be changed by the pilot at any given point in time, because these are designed or defined during the designing of the aeroplane. Okay, what are the four forces affecting on the flight? Lift, because of the difference in the pressure. Thrust is because of the propulsion motion of the of your engines. Weight is because of the downward push is because of the weight of the aeroplane or the drone, and the backward or the opposite direction of the thrust is called drag. This is because of the surface of the device. It could be aeroplane or it could be the drone also. So that's the friction what it causes. Okay, or the difference in the pressure is result in the drag. Bernoulli principle, the simple explanation of the Bernoulli principle is the air will be separated at the leading edge. Okay, the high velocity air flows from the top surface, low velocity flow from the below surface. High velocity will create a low pressure, low velocity will create high pressure. The difference in the air pressure will cause the wing to move upward direction, so that the lift is due to the pressure difference. Okay, this is how the Bernoulli principle happens. We saw the Newton's law of motion. First law states that motion in the rest, the object in the rest will be in the rest. Object in the motion will be in motion until unless external force is applied. When the object is in motion, additional direction or the force will be generated only if the more force is applied on it, or the more force will applied, the more acceleration will cause, okay, to the body or the subject. Third is the opposite and the equal direction force. So action and reaction will happen. So we saw the example of rocket, as well as we also compared the same example with respect to the drone also. Okay, center of lift, center of gravity. The most important part is the center of gravity also always has to be little bit ahead of the center of lift or center of pressure. Okay, this you can test. Okay, like for example, you can take a paper roll. Okay, and put some in that roll, you just put some newspaper inside. Okay, in under, and you tag a string to it. Okay, and you try to balance. Okay, now if you balance the string, okay, in the center, and you try to move that paper roll with your hand, the roll will start moving around you randomly. Okay, it will not give you the shape or the front forward direction. But if you apply little bit more weight to the front of that roll, and then you try to move that roll with the string, the roll will move in a forward direction, so that wherever the weight is more, that will be a forward portion. So, or a nose cone kind of thing, it will try to move in a circular pattern or circular portion. Okay, so that's how you can demonstrate the change of gravity and the center of lift or center of pressure. Okay, aerodynamics comes into play in the study of flight and the science of building and operating an aircraft, which is called as aeronautics. Okay, control surfaces on wing, we have ailerons, which will impact your roll motion. On a vertical stabilizer and horizontal stabilizer, you will have elevators and radars. So elevator will be responsible for the pitch motion, pitch up, pitch down. Okay, whereas the radars will be responsible for changing the heading or changing the directions. Okay, so these are on the vertical stabilizers. On the wings, you will be having engines which will be creating thrust or forward motion of the aeroplane. Okay. Takeoff, flight, and landing we discussed, manual turns and circuit patterns. Circuit patterns. That's how we complete the basic principles of flight. I hope you are clear with the topic on basic principles of flight. Any questions so far?
No.
Okay. So let's. I think Jagjit, you have to leave, right?
Yes, sir, half an hour.
Half an hour. So we'll take a break now, and then we'll start with the DPC procedures. Okay. So let's wind back at 4:30.
Fine, sir.
Okay.
Thank
Let's
you.
take a half.
We log off?
Yeah, not required. Not required. Let's be
Okay.
there.
Okay.
मला आधी वाढ half an hour break. ब्रेक स्प्लिट केला ना त्यांनी. हा ब्रेक 10 मिनिटाचा असतो. तुमको दे देंगे. ठीक है चलिए थोड़ी देर में भेज. Alexa, what is the time? जरा आवाज कमी कर. आता आवाज आहे का? जॉईन झालेले आहेत. मी नाही केली. What is the time?